Hello, sweet friends. Thank you all for understanding uh, this emergency change of plans. Tomorrow will be different. We'll be back in class all together. So, your warm up for today, you're going to look at the model shown. The model shown can represent two number sentences. Which two number sentences can the model represent? Identify the correct answer and circle. All right. So today is Tuesday, November 14th, 2023. I am your teacher, Miss Smith. My email is tsmith@lsoa.org. My number is 682-777-9474. Let's get started. Sorry. So our vocabulary words for today are factor, the number being multiplied, and a multiplication problem. So those are the numbers we are actually using. Product, the answer to a multiplication problem. Fact family. I know we were on the struggle bus. We all were yesterday with fact family. A set of 4 related number sentences or problems that include the same 3 numbers. I have a different, in a few slides, I have a different way we can look at those fact families that we'll get to in a second. Dividend, that total in that whole number, that large number, not the total, the answer, but that large number in a division problem. Divisor, how the dividend, how we are breaking that up, that large number up in a division problem. Quotient, the answer, the amount in each group in a division problem. Variable, we're getting to that. The goal was to get to that today, but until we really get and fully understand what fact families are, we're not going to break into what variables are. You're going to some of you might realize what we're talking about variables some today. If you get it, you get it. If you don't, it's okay. But a variable is just a letter that represents a missing or unknown number. You'll see if you get it today. We are kind of talking about it, but we're not like, you'll see. So once again, dividend, that whole large number in a division problem. The divisor is how are we going to break up that large number into equal groups? And then the quotient is the answer. Factors are the numbers that we are using in a multiplication problem, and the product is our answer. So, fact families. So yesterday we were talking about fact families, and it really it kind of got murky really quickly. Murky, like if you think about like a puddle, after it rains, y'all are saying yesterday, it's raining. And when you go outside right after it rains and there's a big puddle, and the puddle is just fresh rainwater. And then you're like, I'm going to go jump in the rainwater. Once you start jumping in the rainwater, and where the puddle was just clear water at first, then you start jumping in it. And then the puddle is not clear anymore. It's kind of dirty. That's how it got really quickly when we started talking about fact families. It wasn't clear anymore. When we first started talking about it, like, it kind of was clear, but then everyone started talking like, wait, is it this? Is it this? Is it this? It wasn't clear anymore. People started getting really confused really quickly. And then even Miss Smith kind of started getting confused because everyone started asking a lot of questions. So this is how even when I grew up, how I was taught, even in college, how I was taught what fact families are. So we say families because they're all related. Fact families are a set of numbers. Let's go back to that division, that vocabulary word. Fact families, a set of 4 related number sentences that include the same 3 numbers. So they're number sentences or problems, multiplication and division problems using the same 3 numbers. So in this case, it's 3 or 5, 3, and 15 using multiplication and division problems. So if you see, it's 5 times 3 equals 15, 3 times 5 equals 15, 15 divided by 3 equals 5, 15 divided by 5 equals 3. So we don't change those 3 numbers. And because of cumulative property, we can switch up those numbers in multiplication. We can switch up those numbers or factors. We can switch up the 5. We can switch up the 3. We're still going to get 15. 5 is first in the first problem, and 3 is second in the first problem, but we're still going to get 15. We switch them up. 3 is first and 5 is second. Guess what? We still get 15. And then for division, because of cumulative property, I'm probably saying it wrong, 15 is always going to be first because that is our, let's look at our vocabulary word. Let's look at our vocabulary word because our dividend, our big number, that total in the division, that large number that we're going to break up, that can't change, but we can change the divisor, how we're going to group that dividend. We can change the 3, or we can change our groupings. We're going to group it into 3 groups. We're going to group it into 5 groups. And then our product, our quotient will change because of cumulative property. That's what fact family is. Those 3 numbers won't change, but because of cumulative property, that allows it to be a fact family. They're all going to live under the same roof. They're all a family, but and the roof is cumulative property. And they're all a family. Does that make sense? I hope so. And so how I learned it was they're a family. They live under the same roof. And they can switch up places. They can go live in a different bedroom. Maybe they like this bedroom this day and they like this bedroom another day. But because of but they're all going to stay in the same house. Maybe they want to live on the second story. No, I want to live on the third story or whatever. But they're not going to leave this house. So now these are just a few examples of cumulative property or fact families. You can make all of the examples for all of your numbers. For the ones are going to just kind of stay the same because like 1 times 1 times 1 times 1 is the same. But you could do it for the 2s, for the 3s, for the 4s, for the 5s. I have it all for all of them. But I didn't want to put them all on there because that would be a lot of slides. But I just wanted to show that example. I hope that makes a little more sense. And I wasn't going to like sit there and have you guys fill in a fact family, all of those charts either, because that's a lot of filling in. So hopefully that makes a little more sense. So today I want to teach you a new strategy that relates multiplication and division. Multiplication and division work together. It is called fact families. Da, 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 da. What do you know about multiplication and division? And how are they related? Now, this was a question that we were going to do. I forgot the word. The board. You're probably like, Miss Smith. It's the board. The board. whatever the board is called. We're going to do the board. I forgot it. But what do you know about it and how they're related? Multiplication and division, they're opposites of each other, correct? Just like addition and subtraction, they're opposites of each other. Multiplication is the opposite of division. Division is the opposite of multiplication, opposite. So if you know your multiplication facts, if you have the automaticity, you know your division facts. If you know your division facts, you know your multiplication facts. That's why it is so important to have that automaticity. Now, if you don't have it, don't think Miss Smith is going like, oh my goodness, you don't have the automaticity? Because I'm not. We've talked about this a million bajillion times. Miss Smith doesn't have the automaticity. Like, I worked on it through the years, but definitely when I was in third grade, I didn't have the automaticity. I was still modeling it out. And still, for me, I have to picture it. I have to see it. I have to visualize it. To this day, it's so much easier for me to picture it out and model it out. But if you can develop the automaticity, you're going to get through these so much quicker. That's why doing the 99 math is so much better, because it helps you develop the automaticity. So work on knowing your multiplication facts. So let's work through one. There are 10 players. The coach wants to put 5 players on each team. How many teams will the coach have? What type of problem is this? A multiplication or division? Think about it. There are 10 players. The coach wants to put 5 players on each team. I know the total number of players is 10. So which will be my n number? So as you can see, I already have 10 as my n number. But where do I go from here? I've already created a multiplication problem. And so 10 is my n number. And he wants to put 5 players on each team. He wants groups of 5. So I'll put 5 right here. So what times 5 is 10? Now, if I have that automaticity, I can say, what times 5 is 10? And you're probably like, dumbass math, we should unite us. It's blah. But what is blah? Well, I have that automaticity. If I have that automaticity, I can say 5 times 2 equals 10. I can count 5 plus 5 as 10, Miss Smith. Duh, Miss Smith. But what if I don't have that automaticity? I could divide. Well, let's work on another one. Marissa has 36 ribbons to put in 6 bags. Miss Smith needs to learn how to read, doesn't she? She wants to put the same number of ribbons in each bag. How many ribbons should Marissa put in each bag? What type of problem is this? Multiplication or division? Think it out. So I know the total number of ribbons is 36. That's the total number. You have that total number right there. So I have the total number is 36 that she wants to put. And she wants to put 6 in each bag. So I'm going to put 36. I put 36 at my end because that's that total number. And she wants to put 6 in each bag. So what times 6 is 36? If I have the automaticity, I can answer that. And some of you are already like, Miss Smith. if I can talk to you right now through the camera, this is the answer. But guess what? You can't. If you're in chat, you'd be like blowing chat up because you would have the answer right now, wouldn't you? But you can't. You'd be blowing up the mic right now, but you can't. I might like this a lot better. So if we don't have the automaticity, we can, which is, like I said, automaticity, so much quicker. There's another way to do this. What is the opposite of multiplication? Division. We can divide 36 by 6. So let's do that. Let's divide 36 by 6. And you're like, hold up, Miss Smith. I've never seen this way. So everyone take a deep breath. Because I know some of you are already like, she's just thrown something into this that we have never seen before. We don't know what to do here. Miss Smith, this is no, into the no, into the no. And that's okay. All right. Because first, Miss Smith is not going to make you do something we've never done before without Miss Smith walking you through it, right? Totally. I'm not a horribly, horrible, awful person. I might be a horrible, awful person, but not horribly, horribly awful, right? So let's work through it together as a group. So we're doing 36 divided by 6. So what you see right here is a division frame. And this division frame is we're putting that 36 into, we're going to divide 36 into 6. So right here is our checklist. This checklist is just reminding us what we need to do. So step 1, divide. Okay, that's what we're going to do. We're going to divide 36 into 6 and into each number. So here's our first one. So step 1, divide. We're putting it into the division frame. Step 2, multiply. So what are we going to multiply it into? So we've already put our numbers into those, what we're going to multiply into. So how many times does 6 go into 3? We're dividing 6 into 3. That's what we're going to look at first. 6 goes into 3. That's what we're dividing into first. So 6 into 3. We need to figure how many times does 6 go into 3. We're going to do that by multiplying. So 6 goes into 3 we're going to figure that out by multiplying. All right. You're like, wait, I don't know this, Miss Smith. It's okay. We're working through this as a group. So we start by multiplying each number. 6 goes into 3, and we see how many times does 6 go into 3 without going over. 6 goes into 3, so 6, and we go 6 times 0. The 6 times 0 is, anything times 0 is, 0 is our hero, 0. 6 times 1. 6 times 1 is what? It's our mirror. 6. 6 times 2. That's 12. 6 times 3. 18. All right. Remember, we cannot go over 3 because that was the key. I'm going to highlight that, without going over. We've already gone over 3. We cannot go over 3. So we can already, I'm going to just X that one out. That is the key. We cannot go over 3. So let's go down to the next number. How many times can 6 go into 36 without going over 36? So that's your key, without going over 36. How many times can 6 go into 36 without going over? So let's go through this. 6 times 0. Remember, 0 is our hero. 6 times 0, 0. 6 times 1 is the mirror. 6. 6 times 2, 12. 6 times 3, 18. 6 times 4, 24. This is where that automaticity comes in, chickadoodles. 6 times 5. Remember, we can count by fives. 6 times 5, 10, 15, 20, 25, 30. 6 times 6. Remember, it's repeated addition. So if 6 times 5 is 30, if we add 6 more to 30, that is 36. What number are we going to? 36. We don't want to go over 36. 6 times 6 is 36. So how many times can 6 go into 36? 6 times. So the answer to our questions, how many, I forgot, how many ribbons did she want to put into the bag? She wanted to put 6 ribbons in the bag. All right, Eli has 56 blocks to put in 7 bins. He wants to put the same number of blocks in each bin. How many blocks should Eli put in each bin? What type of problem is this? We know it's going to be both multiplication and division if you've been following along. So what happened? We skipped a slide. I don't know what happened to the slide. So what we're going to do is we're going to divide. I don't know what happened to our slide. Nearpod is deleting slides. We're going to divide 7 into 56. So we're going to go through this again. We're going to divide 7 into 5. 7 goes into 5. Remember, we don't want to go over 5. Can we? Let's just check. 7 times 0. Remember, 0 is our hero. 7 times 1 is 7. We already have gone over 5, so we can put a big X in this group. Now, 7 times 56. It took me a second. 7 times 0. 0 is our hero. 7 times 1 is 7. 7 times 2 is 14. 7 times 3, 21. 7 times 4, 28. 7 times 5, 35. 7 times 6, 42. 7 times 7, 49. And 7 times 8 is 56. That What number are we trying to get to? 56. So 7 times 8 is 56. How many boxes Eli want to put into each bin? 8. So our answer would be 8. All right, I'm making sure her name didn't get deleted again. Liz has 15 pencils to put in 5 bags. She wants to put the same number of pencils in each bag. How many pencils should Liz put in each bag? What type of problem is this? We know it is both because of the fact family, multiplication and division. I know the total number of pencils is 15. She wants to put 5 pencils in each bag. So those numbers will be in our multiplication sentence. 15 is at the end. That's my total number. And there are 5 in my sentence. So it should actually be, what is 5 times 15? Miss Smith. What is 5 times 15? So what times 5 is 15? Done, Miss Smith. All right, let's work it out. If we go through each of our numbers, we're going to go through our checklist. Let me get my pen. We're going to divide 5 times 1 without going over. 5 times 0. 0 is our hero. 5 times 0 is 0. 5 times 1 is 5. We've just gone over. It can't be 1. Let's go 5 times 15. 5 times 0 is 0. 5 times 1 is 5. 5 times 2 is 10. 5 times 3, 15. So 15, or 5 times, we're going to 15. So 5 times 3 is 15. Now, 0. So now, and I haven't done this because we were just like really, unless you're like need to go further along. The checklist does say divide, multiply, subtract, bring down. This is how you do it. So we multiply, we subtract. So 5 times 3 is 15. So here is 15. So you bring down your 15, you put your 15 right here. 0 minus, or 5 times minus 5 is 0. 1 minus 1 is 0. And that's how you subtract, just to show it's 0. I'm being a bad teacher. All right, let's do this last one together as a class. I'm just showing you how to do it. And then from there, you're on your own, chickadoodles. Max has 45 beads to put in 9 boxes. He wants to put the same number of beads in each box. How many beads should Max put in each box? What type of problem is this? We know multiplication and division. I know the total number of beads is 45. He wants to put in 9 boxes. So those numbers will be in my multiplication sentence. So 45 is the total number. 9 is in my sentence. So what times 9 is 45? So let's go through and check this out. We're going to divide first. So 0 times 9 is 9 times 0. Remember, we don't want to go over 4 because we're starting with 4 first. 0 times 9 times 0 is 9. 9 times 0 is 0. 9 times 1 is 9. put an X there. And yes, they're sleeping. Sorry. All right. Sorry. Brain hiccup. Okay. Then we're doing 9 times 45. Go down to 45, Miss Smith. Use your brain. 9 times 0 is 0. 9 times 1 is 9. 9 times 2 is 18. 9 times 3. Brain hiccup. Brain hiccup. Use your brain. Y'all are like, Miss Smith, use your brain. 9 times 3. 18. 27. It's coming together. 9 times 4 is 36. 9 times 5, 45. Remember, we're going over 40. We do not go over 45. So 9 times 5, we're bringing 0. That's because remember, 0 right here. We put our 0 right here. 4, 5, 45, 0, 0. Here we go. All right. So 45 divided by 9 equals 5. How many beads does he put in each box? 5. So what are you doing? You're going to answer this question. There are a total of 63 carts in 9 rows. At the grocery store, there are the same number of carts in each row. Write the fact family that can be used to find the number of carts in each row. So you're going to create a multiplication problem and then do the cumulative property for this multiplication problem. You already know the total. It is 63. You already know one of the factors. It is 9. So what is the other factor? You already know the dividend. It is 63. You already know the divisor. It is 9. What is the quotient? Figure it out. And I have given you that to also work through. We need to get there. And then this is your exit ticket. There you go, my friends. I love you. Love you. I will see you tomorrow. I will get you'll also complete your ELA ticket as well, or ELA lesson as well. Hasta la pasta.